mentioned previously that one of the main reasons we write complex numbers in trigonometric, or in other words, polar form, is so that we can effectively work with roots and powers of complex numbers much more efficiently. So I want to start by taking a look at a complex number that is in standard, or that is in trigonometric form. So z is equal to r cosine theta plus I sine theta. And if we were to multiply a complex number by another complex number, so for example, z squared would be equivalent to saying r cosine theta plus I sine theta times practically itself, right? R cosine theta plus I sine theta. And in the previous lesson, we looked at multiplying complex numbers in polar form. And all that means is we're just going to multiply our moduli. So this would be r times r, or r squared. And we would say cosine of the sum of our angles. We would then add this angle to this angle. So that's theta plus theta plus I sine, and we do the same thing with those angles, theta plus theta. In this case, we happen to have the same angles. So we have this. Well, if I clean this up just a little bit, r squared, what do we have? We have cosine of 2 theta plus I sine 2 theta. Well, okay, that's a little bit interesting. And if we were to do the same thing now to z cubed, basically take this result that we just found for z squared and multiply it by z again, what would we get here? Well, that would be r squared times another r, so that would be r cubed. And I'm going to write this in abbreviated form, just this for the sake of time, CIS, and then we would have 2 theta plus another theta. Well, that would just be 3 theta. And if you take a step back and you ask yourself, do I notice any type of pattern with the powers and what is going on with our angles here? And hopefully you see it. If you see that, that, and that, do you notice a pattern there? Well, this really smart dude named DeMoivre did. And he effectively was able to summarize what we're seeing here as the following. Raising any complex number to some power, let's write in general terms, that some power n, let n be that power, is equivalent to just taking that modulus, raising it to the power of n as well, and writing this as cosine n times, and that angle, it's the coefficient of that angle, plus I sine n theta. Or if we were to write this in abbreviated form, this would be r to the n cis n theta. And that's DeMoivre's theorem. And this allows us to work with powers of complex numbers way more efficiently. Take, for example, something like number 4. If I asked you to find I1 minus I root 3 and raise that to the 8th power, up to this point, our only option that we would have had would be to expand that out to have 8 different factors of 1 minus I root 3 and multiply all that together. But hopefully we'll be able to do this a little bit more efficiently. So let me go ahead and do 2 with you. One example where the number or the complex number is in trigonometric form, and then we'll do one where the complex number is still in standard form. So let's take a look at something like number 1 here. Well, we've got 3 times cosine 150 plus I sine 150, and we're going to raise this complex number to the 4th power. So to say the following, z to the 4th, z being our complex number raised to the 4th power, is the following. We have our modulus, which is 3, so 3 raised to the 4th power. And I'm just going to go ahead and write CIS, or, well, you know what? Let me write it out since this is the first time we're doing this problem. Cosine of our n value now is 4, so it's going to be 4 times 150, 4 times our angle 150, plus I sine, again, 4 times 150. And let's actually just expand this out. What do we have here? We have 3 to the 4th, which is 81. We have cosine of 600 degrees plus I sine 600 degrees. And let's find a coterminal angle because 600 degrees is a little bit beyond 360. So if we subtract 360, that's equivalent to cosine of 240 degrees plus I sine 240 degrees. And if we think about where 240 degrees is, that's in quadrant 3. Let me just draw that. 240 degrees, that's 60 degrees beyond 180. So there's 240. And we would then say we have 81 times -1/2 plus √3/2i. Well, if we clean that up, we would then get the following. -81/2 plus 81√3/2i. So there's our power. So that is this complex number that's written up here, this complex number raised to the 4th power. And there it is written in standard form. Let's try another example, but this time we have the number that's already written for us in standard form. So what we're going to want to do, since this number is written in standard form, is to first write it in trigonometric form. So 1 plus I, think about where that number is. Well, if this is 1 and this is 1i on the imaginary axis, our number is right here in quadrant 1. So we know by looking at our complex number in standard form that r is equal to, remember, it's distance from 0, so I'm just going to do the distance formula. So there's 1 plus 1 squared plus 1 squared, so that's √2. So r is equal to √2. Well, what is theta? Theta would be the arctangent or inverse tangent of 1/1, which you don't need a calculator for. Hopefully you know that this is equal to pi/4. So this complex number, 1 plus I, is the same as writing z is equal to r modulus √2 cis pi/4. Now, I'm going to take this complex number that's in trig form, and I'm going to raise it to the 6th power. So I'm going to take all this and I'm going to raise it to the 6th power. And using DeMoivre's theorem, that's way easier than actually taking this original standard form and multiplying it with 6 factors. What would we get? We would get √2 raised to the 6th power, cis 6, which is our n value, times pi/4. Well, √2 raised to the 6th power, well, that's just going to be 2 raised to the 3rd power. So there's 8 cis, and we get that simplified would be 3pi/2. And there's our answer in trigonometric form, but we should write our answers in standard form. So if we evaluate here, we have 8 times the cosine of 3pi/2, which is just 0, plus I times the sine of 3pi/2, which is -1. So this, again, this was our trig form. Let me write that. This is trig form. And if we finish evaluating this here, this would be 0 minus 8i, or just -8i. There's our answer now in standard form. Okay? So go ahead and try the next 2 problems, numbers 2 and 4. Give those a go on your own and check those with the solutions that have been uploaded.